In the 20th century, major strides were made in controlling once widely feared scourges like tuberculosis, bacterial pneumonia, and post-surgical infections. With the development of antibiotic drugs, infections that once caused widespread disability or even death were instead treatable, thereby improving quality of life for people and animals while offering other advantages in agriculture. Yet with all the benefits of antibiotics, their widespread use has resulted in increasing incidence of resistance or the ability of some bacteria to survive, grow, and continue to cause infection in the presence of these drugs. Antibiotic resistance is a serious human and animal health threat. According to the U.S. Centers for Disease Control, approximately 2 million people in the United States become ill every year with resistant infections, and of those who become ill, approximately 23,000 die. In this video, learn how Virginia Tech is responding to better understand this public health challenge.
I'm Amy Pruden, and I'm a professor of civil and environmental engineering at Virginia Tech. I'm the principal investigator on a U.S. Department of Agriculture grant where we're looking at the potential for antibiotic resistance to spread from manure to fresh produce. So the basic question we're trying to answer is, what's in your fresh produce? We know that it's not a sterile environment. There's plenty of bacteria there, and most times they're perfectly harmless, and who knows, maybe even beneficial. But sometimes, very rarely, there are pathogens there, like E. coli. And a lot of work has been done and protections put in place to protect us from pathogens. But we're taking a different angle. We want to know if it's possible for antibiotic resistance to spread through produce eaten raw, such as lettuce and carrots and broccoli and radishes.
Food animals like beef cattle, dairy cattle, chickens, turkeys, and pigs receive antibiotics just like people do. FDA-approved uses of antibiotics include disease treatment for sick individual animals or animals in herds that are sick, disease prevention for a group of healthy animals that are at risk of becoming sick, and growth promotion or increased feed efficiency in a herd or flock of animals to promote weight gain. However, antibiotics important for human health are recommended to be used in food animals only to treat disease and under the guidance of a veterinarian. Plus, the United States has strict controls to prevent antibiotics from being in our meat or milk. So how does this impact the development of antibiotic resistance? Whenever antibiotics are used in humans or animals, antibiotic residues are excreted in feces and urine. A residue is what remains in the body and is excreted after the majority of the drug has been metabolized or broken down. Also, anytime antibiotics are used, there's the potential there may be bacteria present that are resistant to that antibiotic. These bacteria will survive and grow better than other bacteria in the presence of the antibiotic or be selected. Sometimes bacteria mutate and become resistant, and sometimes they can share their ability to resist antibiotics with other bacteria, enter wastewater, soil, and compost, and when that material is used to grow food crops. This 3-year project aims to identify strategies for mitigating the spread of antibiotic-resistant bacteria, starting at the farm all the way to the fork, by looking at 5 critical control points along the way. 1. Antibiotic use in food animals. 2. Different manure composting methods. 3. Amendment of manure or compost to different soil types. 4. Different vegetable crops. And 5. Post-harvest washing practices. One highlight of this research is state-of-the-art laboratory methods, especially metagenomics, to look for bacterial genes that confer antibiotic resistance. Antibiotic resistance genes in the environment pose special concern because they may be taken up and shared by active bacteria, which then have the ability to resist antibiotics. Research is just starting to show how this method is involved in the spread of antibiotic resistance.
This is very much a team effort and would not be possible without an environment like Virginia Tech. We're a land-grant institute with a mission of service, and we have a strong extension program, and we've been working closely with the producer and grower communities.